Okay, so we're again going to continue chapter 1. In today's lectures, we'll look at conditional and biconditional statements. Now we're familiar with statements of this type, like if P then Q, right? So statements of these types, and it's intuitive, they're conditional statements. And the symbol for conditional statements is P and then this arrow and Q. So again, this is like if P then Q, right? So now this is a logical expression, right? And we need to look at the truth table for this. Now the logic behind, so every logical expression has a logic behind it, right? And sometimes the logic can be tricky. So in this case, the logic behind the truth table for this logical expression is a bit tricky. So we'll look at an intuitive scenario. So this is given in Zybooks. Now, think of the conditional statement as a contract. And so it's like a contract that favors the worker, right? So let's say that Mr. Smith wants to get his lawn mowed, right? And then he'll pay the worker, right? So this is your P, right? And this is your Q. If you mow Mr. Smith's lawn, so that's P, then he will pay you, right? Now, this is a particular type of contract in which, again, this favors the worker. Right. So now this is a table where P is true over here, which means that you mow Mr. Smith's lawn, and if you do not mow Mr. Smith's lawn, then P is false. And this is Mr. Smith paying you, right? Q is true, means Mr. Smith pays you, and then Q is false, means Mr. Smith does not pay you. Now, in one of these conditions, right, the contract breaks. So it's a bit non-intuitive, but again, think about the contract favoring the worker. Now, if you mow Mr. Smith's lawn, Mr. Smith pays you. Makes sense, right? This is intuitive. So you get a true over here. If you mow Mr. Smith's lawn, Mr. Smith does not pay you. So that's also intuitive. The contract breaks because you were not paid. Okay, so that's false. So when the contract breaks, you get a false. Right? Now, if you do not mow Mr. Smith's lawn, Mr. Smith still pays you. Right? This is the part that's a bit non-intuitive. So that's why I say that it's a contract that favors the worker. Mr. Smith decides to be generous, and he says, okay, I'm not going to break the contract, even though you did not mow my lawn. So you still get a true. The contract stays intact. And if you, so this is the part which is also intuitive. Nothing happens. You do not mow the lawn. Mr. Smith does not pay. So the contract stays there. And so this is sort of like an example that makes it more intuitive on how this conditional statement works. And so this is the only part, right, where P is true, where P is true and Q is false, you get a false. So whenever the first one is true, the second one is false, you get a false. That's another way of remembering the conditional statement, the truth table for the conditional statement. And in all other cases, the contract stays intact. Now, another type of biconditional statement. So the biconditional statement is more intuitive. It's like a more balanced contract where if you do not mow Mr. Smith's lawn, you do not get paid. So for the biconditional statement goes both ways. So it's that's why it does not favor the worker. It's more balanced. So this is going to be false for the biconditional statement because you did not mow Mr. Smith's lawn. And so Mr. Smith pays you, that breaks the contract. It's a false value. It's not going to happen. So, because you did not do your work. So in that case, you can see that the biconditional statement, right, is false in this case, which is the case we discussed, and this is the difference, and this is the case where you do not mow the lawn and Mr. Smith pays you. That breaks the contract. Okay, so this is now you can show that. So now these conditional statements that we looked at, these can be equivalent to other logical expressions. And so again, we talked about equivalency in the previous lecture. So if if you want to show that P is equivalent to Q, then not P is equivalent to, sorry, if you want to show that P, the conditional statement P, if P then Q is equivalent to not P or Q, you need to draw their truth tables. And so we know the truth table we just discussed the truth table over here. You can construct the truth table for not P or Q. So again, you start with true, true, false, false. The Q goes true, false, true, false. And then since you want not P or Q, so you need to add a column for not P, right? So that you can do not P or Q. So then the OR operation works the usual way. The not of P is the opposite of this column. So that's false, false, true, true. And so the OR operation is, again, OR is only false when both of the values are false. So you only get a false over here. So now you can see that this is just the same column. The final columns are the same. And therefore, these two logical expressions are equivalent to each other.